A bottlenose dolphin drives its skull into a harbor porpoise until the ribs collapse. Then it swims away. It eats none of it. The body sinks slowly, and the dolphin's face never changes. Same curved jaw, same fixed expression we've been calling a smile since before most of us were born. It isn't a smile, it's bone. The easy explanation is competition over food, except these two animals often aren't hunting the same prey. And this is one of the milder things dolphins do. The behavior isn't the mystery. The brain running it is. So start with the face. Pull up any photograph of a bottlenose dolphin. The head breaks the surface, the beak angles slightly upward, and the line of the mouth curves back toward the eye in a soft, unmistakable arc. Your brain does the rest before you've had a conscious thought about it. It reads friendly. It reads pleased to see you. Every aquarium poster, every children's book, every stock image of a hand reaching down from a boat rail is built on that single curve. It is probably the most successful piece of accidental advertising in the animal kingdom. And it is not an expression. Nothing is being expressed. You are looking at the outline of a skull. Strip the skin away in your mind. Underneath, the upper and lower jaws of a bottlenose dolphin meet along a line that bends upward at the back. That bend is structural. It's there when the animal is hunting. It's there when the animal is sick. It's there when the animal is dead on a beach with gulls standing on it. The curve doesn't move because the bone doesn't move. Lay a dolphin skull over a photograph of a living one, and the famous smile lines up exactly with the join between two rigid pieces of bone. We have spent decades interpreting architecture as emotion. Your face works differently, and the difference is not small. Human faces carry a dense sheet of muscle that anchors into the skin itself rather than to bone at both ends, which is why your skin can move independently of your skull. That's what a smile physically is. Soft tissue dragged into a new shape and held there. It's a signaling system, and it evolved because our ancestors lived in groups where being able to broadcast intent across a few meters of air was worth the anatomical investment. A dolphin has almost none of that machinery around the mouth. The skin over the rostrum is tight, smooth, and effectively locked down. There are no cheeks. There are no mobile lips. There's no loose tissue to pull. Even if a dolphin desperately needed to show you something, the front of its face has no vocabulary to show it with. Here's where it gets stranger. The facial muscles didn't disappear. They were relocated and put to work on something else entirely. Move up and back from the beak toward the blowhole, and you find one of the most elaborate arrangements of facial musculature of any mammal alive. Layers of tissue wrapped around the nasal passages, capable of extremely fine, extremely fast control. That equipment is not building expressions. It's building sound. Air gets pushed through structures inside the head, driven and shaped by those muscles. And what comes out the other side is a click, a whistle, a burst pulse squawk. The face of a dolphin is not a display surface. It's a musical instrument. And every muscle that a human would spend on a raised eyebrow has been reassigned to the production of noise, which explains the forehead. That smooth, rounded dome above the beak isn't skull and it isn't muscle. It's a body of specialized fatty tissue, and its job is to take the sound generated behind it and push it outward into the water in a controlled beam. That shape you find so appealing, the one that makes a dolphin look almost cartoonish from the side, exists because sound needs somewhere to go. Nothing about the head is aesthetic. Every visible feature is solving a problem in physics. Now subtract a sense. An adult bottlenose dolphin has no functioning olfactory bulb. The hardware for smell, a foundational sense for almost every other mammal on the planet. The thing a dog builds its entire world out of is simply not there. Gone. Evolution deleted it, and the space and neural budget went somewhere more useful, for an air-breathing hunter in water. Think about what that means for the face. Most mammal faces are organized around a nose, A dolphin's face is organized around a transmitter. The nostril migrated to the top of the head and became a valve for breathing and a component in sound production. There is no nose on the front of that animal. There never was one in the way you're imagining it. The receiving end is just as unfamiliar. Look for ears on a dolphin, and you'll find pinholes behind the eyes that barely register in a photograph. And those aren't doing the heavy lifting. Much of the sound coming back from the water enters through the lower jaw, travels through fat-filled channels inside the bone, and is delivered to the middle ear that way. The jaw is an antenna. The forehead is a speaker. The mouth line you've been reading as a smile is the outer edge of a hearing organ. That entire front section of the animal, the part we anthropomorphize hardest, is a sound system with teeth in it. The teeth are worth a second of your attention because they follow the same rule. They're conical, they're near identical along the whole jaw, and they don't chew anything. There's no grinding surface, no shearing edge, no molars. They exist to grip a struggling fish long enough to swallow it whole, usually head first, so the fins fold flat going down. That's it. A row of holding pins. And they're permanently visible in that curve we find charming. And the eyes are not where you think they are. They sit far back on the sides of the head, angled outward, which means the head-on portrait every camera loves is close to the one angle a dolphin isn't built to look at you from. Each eye covers its own field, and they can be aimed independently. A mammal eye should be badly wrong in at least one medium, blurred in water or unfocused in air. A dolphin's works in both, and it's coated in a thick, oily mucus that shields it from salt and abrasion. In a still photograph, that eye looks soft. It's shielded optics on a swiveling mount. Even the last soft detail on the face has been stripped out. Bottlenose calves are born with a line of tiny hairs along the top of the beak, and within weeks, those hairs fall out and never regrow. What's left are small pits in the skin where they used to be. In at least one dolphin species, those leftover pits have been shown to do something unexpected. They appear to detect the weak electric fields that living bodies produce in water, meaning the ghost of a whisker system was repurposed into a completely different sense. That's the pattern repeating. Nothing on this face is what it looks like. Everything has been converted into something else. And there's a cost to all of this, one that lands squarely on us. An animal with no facial expression has no way to tell you it's in trouble. A dolphin with a serious internal problem, a dolphin that has been circling the same tank for 11 years, a dolphin with a stomach ulcer or a healing puncture wound or a chronic infection, looks exactly like a dolphin that is fine. The photograph is identical. That fixed curve of bone has been photographed millions of times in facilities around the world, and the visitors reading it as delight had no chance of reading it as anything else, because the animal cannot produce a second option. Former trainers have been making this exact point for a long time now, and it never quite lands because the image is stronger than the argument. You can be told the smile is bone, and still feel that it's a smile. That's not stupidity. That's your face-reading wiring doing what it was built to do, on an animal it was never built for. Then there's the other use of that beak, the one we started with. The rostrum is a long, dense, reinforced structure of bone driven by a body that can accelerate hard in a very short distance, pointed at something soft, and it stops being a sensory platform and becomes a spear with a body behind it. The injuries recovered from dead harbor porpoises, collapsed ribs, ruptured organs, damage clustered on one side of the torso, are consistent with that kind of impact, delivered repeatedly. Same face, same curve, same photograph. So the first thing to accept is this: we were never looking at the animal. We were looking at a shape, and we filled it in with ourselves. Strip the projection away, and the face turns into hardware. A transmitter, a receiver, a grip, a weapon, and no signal at all for anything happening inside. Which raises the obvious problem. Dolphins are social to an extreme degree. Groups form, split, reform, negotiate, ally, and turn on each other, and none of that is possible without communication. If the face is silent, everything has to move into sound. All of it. Identity, location, threat, coordination, argument. That's an enormous amount of work to push through a single channel. And running a system like that demands a nervous system that essentially never gets to switch off. It doesn't. And what a dolphin has to give up to keep it running is the part almost nobody mentions. Try an experiment you will lose. Sit somewhere quiet and take control of your own breathing. Every inhale, every exhale, deliberate. Count them. Somewhere between 2 and 10 minutes, your attention slips, and the automatic system underneath takes over without asking permission. You cannot hand your breathing back and forth forever because you were never running it in the first place. A brainstem does it for you all night, every night, without consulting you once. A dolphin has no such arrangement. Every single breath a bottlenose dolphin takes in its entire life is a decision. The blowhole does not fall open. It's held shut by muscle and opened deliberately at the surface. In a window of roughly a fifth of a second, surface, blow, refill, close, gone. Miss the decision and water goes in. That's the whole system. There is no backup, no autopilot, no reflex that saves the animal if the mind stops paying attention. Now put that animal to sleep and watch what happens. Nothing does, because it can't. This is the trade at the center of everything a dolphin is, and it gets mentioned in passing as a fun fact. Half the brain sleeps at a time, as though that's a quirky detail rather than a description of a life with no off switch. Recordings of brain activity in bottlenose dolphins show one cerebral hemisphere dropping into deep, slow-wave sleep while the other stays in a waking pattern. Then, after a stretch, they trade. The sleeping side wakes, the waking side goes under. The animal keeps swimming the entire time. It keeps surfacing. It keeps breathing on schedule. At no point in a healthy adult dolphin's life is the whole brain unconscious at once. The visual giveaway is the eye. Because of how the wiring runs, the eye on the opposite side from the sleeping hemisphere tends to close, and the other one stays open. So a resting dolphin, hanging near the surface in that slow, drifting posture, is watching. Half of it is asleep. Half of it is looking directly at whatever is nearby. If you have ever stood at the edge of a pool at night and seen one eye tracking you from an animal that appeared completely still, you were not imagining the attention. You were seeing exactly half a mind. There's a detail here that keeps coming up in observations of mothers, and it's the kind of thing that lands harder the longer you sit with it. The open eye is often the one pointed at the calf. Whether that's a deliberate choice or a consequence of how they position themselves is not fully settled, and it should stay unsettled. Inferring intent from swimming posture is exactly the trap this whole story is about. What isn't in doubt is the outcome. The half of the brain that stays awake is the half connected to the eye that can see the offspring. Which brings up the worst version of this. What happens when the calf is newborn? Studies that have tracked mothers and newborn bottlenose dolphins through the weeks after birth describe something that shouldn't be survivable. The calf swims continuously from the moment it's born. It has to because it has to breathe, and it hasn't learned to rest yet. It stays glued to the mother's side, riding the pressure wave off her body, and the mother matches it. For weeks after birth, both animals show almost no rest behavior at all, not reduced sleep, something much closer to none, sustained for a period that would kill a human being several times over. Then, gradually, rest returns. No obvious collapse. No catastrophic crash. That is the part that unsettles researchers, Because in every land mammal we've studied properly, sleep loss builds a debt, and the debt gets paid with interest or the animal starts falling apart. Immune function, memory, temperature regulation, eventually organ failure. Dolphins do not appear to pay it back the same way. Whether they've genuinely escaped the cost or simply pay it somewhere we haven't learned to measure remains an open question. Nobody should be claiming a solved answer on that one, but the observation stands, and it's the kind of observation that quietly breaks a rule you didn't know you were relying on. Push it further. In controlled experiments, dolphins have been asked to keep performing a listening task. Detect the target, respond, repeat. Continuously, around the clock, for days, not hours. Days. The accuracy stayed effectively flat, no degradation curve, no lapses of the kind a human operator produces within a single overnight shift. An air traffic controller starts making errors after a long night. This animal did not. So the picture is an intelligence that runs permanently, watching with one eye, listening constantly, breathing by choice, and apparently paying far less for it than physics suggests it should. Now the cost side, because there is one, and it's severe. If a dolphin loses consciousness, it dies. Not eventually, immediately, in the ordinary way that any air-breathing animal dies underwater. This is why entanglement is so lethal. A dolphin caught in netting doesn't have hours. It has the length of a single breath hold, and then the system that requires a conscious decision every few minutes fails, because the decision can no longer be executed. Every year, enormous numbers of small cetaceans die exactly this way, in gear that was never aimed at them. They don't die of injury. They die because they couldn't get to the surface to make a choice. The same constraint turns routine veterinary work into a genuine problem. Anesthesia does precisely what a dolphin cannot afford. It shuts down the whole brain at once, including the part making the breathing decision. Historically, this made general anesthesia in cetaceans dangerous enough that it was avoided wherever possible, and getting around it required building systems to take over ventilation entirely, rather than trusting the animal to keep breathing on its own. Think about what that says. Standard procedures that are unremarkable in a horse or a dog become high risk in a dolphin because sedating one means removing the only thing keeping it alive. There's another absence in the picture, and it's the strangest one. In humans and most land mammals, sleep isn't only slow waves. There's REM, the phase where the brain lights up, the eyes move, muscle tone collapses, and dreams happen. It's tied to memory consolidation and to development. In cetaceans, clear REM sleep has been very difficult to find. Some brief muscle twitches have been reported, nothing resembling the long, unmistakable REM blocks that show up in a sleeping cat. The honest position is that we don't know whether they have it in some reduced form, whether the half-brain arrangement makes it undetectable with current methods, or whether they've genuinely dispensed with it. It's an active argument. And the reason it matters is that muscle paralysis during REM would be fatal for an animal that has to swim to breathe. Whatever the answer turns out to be, the environment set the terms. Step back and look at what this means for the animal we're actually trying to understand. A dolphin never gets the thing you get every night: the clean break, the hours of nobody home, the reset. It has no unconscious. It has no period where the world stops existing and something quietly reorganizes the day. It runs continuously from birth to death, one half at a time, at the surface of a fluid that will kill it if it stops making decisions. And half of a dolphin brain is not a small amount of processing. This is an animal with a large, densely folded cortex, sustained across a life that can run for decades. Whatever that hardware is doing, it is doing it right now, in every dolphin alive, without pause. So the question stops being whether they're smart. That question is boring, and it's been answered badly for 50 years by people holding fish. The real question is what all that permanently running capacity is being spent on, because evolution does not fund an organ that expensive without demanding returns. The answer is not vision. Underwater visibility is often measured in meters, and for a hunter chasing fast fish through murk or dark, eyes are close to useless. The answer is not smell. That hardware was deleted before it ever got started. The answer is sound. And a dolphin's relationship with sound is not like anything you have experienced. It isn't a better version of hearing. It isn't the underwater equivalent of sight. It's a sense that goes through solid objects and comes back with information about the inside of them. And once you understand what that actually means in a group of animals living together, the social behavior in the rest of this story starts to look very different. Close your eyes and have someone drop a coin on the floor across the room. You'll know roughly where it landed. That's echolocation in the crudest possible form. A sound, a delay, a direction. Now imagine doing it several hundred times a second, on purpose, with a beam you can aim, at a target the size of a golf ball, from further away than you could see it on a clear day above water. That's the baseline. And it still isn't the strange part. The strange part is what the sound does when it arrives. Start with production, because the anatomy sets up everything that follows. The clicks are not made in the throat. They're made high in the head just below the blowhole, where air is forced past a pair of tissue structures that snap together and generate a pulse. Those structures sit inside that elaborate nasal musculature we've already met, the equipment that would have been building facial expressions in any other mammal. The pulse then passes forward into the melon, the fatty dome in the forehead, which has a graded internal structure that bends sound the way a lens bends light. Fat of different densities, layered deliberately. The dolphin isn't just making a noise, it's focusing one. What comes out is narrow, directional, and extremely powerful. Dolphin clicks are among the most intense sounds produced by any animal, packed into pulses lasting a fraction of a millisecond. Short pulse, huge amplitude. That combination is what buys resolution. The shorter the click, the finer the detail it can resolve on the way back. And it comes back into the jaw, not the ears. The lower jaw of a dolphin is thin-walled at the rear and filled with a specialized fat that carries sound almost perfectly into the middle ear. The pinholes behind the eyes are close to vestigial for this purpose. The animal is listening with the front of its head, and the front of its head is also the thing with teeth in it. Watch the acoustic pattern of a hunt and it stops being abstract. Cruising, a dolphin puts out clicks at a slow, spaced rate, a few per second, scanning. Lock onto something, and the rate climbs. Close in, and the spacing collapses into what's called a terminal buzz, hundreds of clicks per second, a continuous tearing sound, rather than individual pulses, ending at the moment of capture. The frame rate goes up as the target gets closer. If you have ever heard a recording of a dolphin catching a fish, the sound rising into a hard electric rasp right before contact, you are hearing the resolution being cranked to maximum in the last half second. Now the reversal, and this is the piece that changes how the rest of the story reads. Light stops at surfaces. That's the entire basis of vision. Photons hit the outside of an object, bounce, and you build a picture of the skin of the world. You have never seen the inside of anything without cutting it open or borrowing a machine. Sound in water doesn't behave that way. Water and soft tissue are acoustically similar enough that a click passes into a body, rather than simply bouncing off it. It travels through muscle and fat. It reflects at boundaries where density changes sharply: bone, cartilage, and above all, air. A fish's swim bladder is a gas-filled sac in the middle of a water-dense body. Acoustically, it's a lantern. It reflects far harder than anything else in the animal. which means a dolphin scanning a shoal isn't detecting fish-shaped outlines. It's detecting the bright internal organ inside each one and reading size, depth, and species from it. The fish's most private structure is the loudest thing about it. Controlled work with trained dolphins has pushed this much further. Presented with objects that look identical from the outside, dolphins can discriminate between them based on what's inside. Differences in wall thickness, in the material, in internal structure. They sort hollow from solid, one metal from another, thick-walled from thin-walled. Not by touching, by listening to the echo returning from the interior. The information a dolphin gets from a click is closer to a density map than a photograph. Sit with the implication for a second. Point that sense at another animal, and you are not looking at its surface. You are getting its lungs. The largest airspace in any mammal body, and therefore the brightest possible target. You get its skeleton. You get the gas in its gut. You get, in principle, whether there's a second, smaller set of lungs inside the first body. This is where the popular version runs ahead of the evidence, and it needs flagging clearly. You'll find claims online that dolphins can detect human pregnancy, sometimes attached to stories of animals in swim-with programs taking sudden interest in a particular woman. The physics is not absurd. A fetus is a dense, structured mass with its own developing skeleton sitting inside an abdomen. But interest in a swimmer is not a diagnosis, and there is no solid body of published work demonstrating that dolphins detect and identify pregnancy in humans. What's reasonable to say is narrower and still remarkable. Their sense is penetrative. It resolves internal structure, and the boundary of what they can extract from a body has not been mapped. Treat anything beyond that as a story people enjoy telling. What's much better supported is what this does to life inside a group. Dolphins can hear each other's clicks. A click aimed at a fish by one animal produces echoes that every dolphin nearby also receives. Eavesdropping on a neighbor's echolocation is well documented, and it means a hunting pod isn't a collection of individual sensors. It's a shared acoustic field, with information leaking constantly in every direction. When one animal scans, everyone gets a partial copy. Now push that into the body. A dolphin's own physical state has acoustic consequences. Lung volume changes with breathing and with depth. Muscle tension, gut contents, injury, the presence of a late-term calf. These are physical facts about the interior of a body. Sitting inside a group of animals whose primary sense reads interiors, there is no serious evidence that dolphins run diagnostics on each other. Nobody has demonstrated that, and it shouldn't be asserted. But the geometry of the situation is not in dispute. In a pod, you cannot hide the inside of yourself. Whatever is happening in there is to some degree available to every animal within range, whether or not anyone is deliberately looking. Compare that to your own social life, which runs almost entirely on things you choose to display. Face, posture, voice. You can lie with all of them. A dolphin's face broadcasts nothing at all, as we've established, and its body broadcasts everything constantly without consent. The signaling channel is dead. The involuntary channel is wide open. That is close to the inverse of the primate arrangement, and it's worth holding on to as this story gets darker. One more open question belongs here, because it's been argued about for decades, and it isn't settled. Given how loud those clicks are, the idea has circulated that dolphins might use sound offensively, that a concentrated burst could stun or disorient a fish, making capture easier. It has an appealing logic. Observers have described fish behaving oddly in the presence of hunting dolphins, and some cetaceans do produce extremely intense low-frequency sounds during foraging. But the evidence has never been decisive. Attempts to demonstrate acoustic stunning under controlled conditions have produced mixed and often negative results, and other explanations for the fish behavior are available. The current honest position is that it remains plausible, unproven, and disputed among the people who study it most closely. It is not a fact. It's a live argument. And it's more interesting as an argument than it would be as a settled answer. What isn't disputed is the shape of what we've built. Take an animal with no facial expression and no capacity to signal intent with its body. Give it a brain that never fully sleeps, then hand it a sense that passes through flesh, resolves the interior of other bodies, floods the surrounding water with information that everyone else can also hear, and functions perfectly in total darkness. Then put 50 of them together for 60 years, with overlapping generations and long memories. That's not a school of fish. That's a society. One where everyone knows what's inside everyone else, where nobody can show anything on their face, and where every relationship has to be built and broken through sound alone. Societies like that develop structure. They develop factions. And in bottlenose dolphins, the structure that emerged has almost nothing to do with the peaceful family pod on the aquarium wall. It starts with the males. Here's the image most people carry: a pod of dolphins moving together through open water, mothers and calves and uncles, a family unit crossing the ocean as a single peaceful body. It's on documentary covers. It's what the word pod makes you picture. It isn't how bottlenose dolphin society works. Bottlenose dolphins live in what's called a fission-fusion system, and once you understand the term, you can't unsee it. Groups form, hold for an afternoon, dissolve, reform with different members by evening. An individual might spend the morning with 6 animals and the night with 2 entirely different ones. There is no fixed troop. There is no stable herd. What exists instead is a fluid social field of hundreds of individuals in a single bay, all of whom know each other by name. Because signature whistles function as names, learned in the first months of life and kept for decades, and who are constantly making decisions about who to be near and who to avoid. And the naming is not passive. Dolphins have been recorded copying another individual's signature whistle and producing it, which is the acoustic equivalent of calling someone's name across a room. In playback work, an animal that hears its own whistle copied tends to answer. So the bookkeeping isn't only happening inside a head. They can address each other directly, by name, across water, where nobody can see anyone's body, let alone their face. That is a far harder society to run than a family. A wolf pack has a structure you can draw. This has to be held entirely in memory, updated continuously across dozens of relationships that change by the hour. And here is the thing to hold on to. This is the workload. This is what that never-sleeping brain is for. Not tool use, not tricks. Bookkeeping on other dolphins. Now watch what the males built inside it. The long-running work in Shark Bay, Western Australia, has followed the same individually identified dolphins for decades. And what it documented there reorganized how anyone thinks about non-human social structure. Adult males don't operate alone. They form alliances. Small, tight, extremely durable partnerships of 2 or 3 animals that can persist for years, and in some cases for the better part of a lifetime. These pairs and trios swim in near-perfect synchrony. They surface together, breathe together, turn together, sometimes matching each other so precisely that from above they read as a single organism with 3 dorsal fins. That synchrony is not decoration. Coordinated display appears to advertise the strength of the bond itself, a way of showing other males, and possibly females, that these animals move as one unit. Partners in the tightest alliances also produce vocalizations in a coordinated way. Whatever else is happening, it's a relationship being performed in public, constantly, for an audience that is always listening. So far, this could still be a story about friendship, cooperation between males, loyalty across years, coordinated movement. It sounds almost admirable. It's the standard framing, and it's how these alliances usually get presented in a nature documentary before the camera moves on. Then you find out what the alliance is for. The function of a first-order alliance is to locate a single female and take control of her movements. 2 or 3 males converge on one female, position themselves on either side and behind, and keep her there. This is called a consortship, which is a very calm word for what the behavior actually looks like. The males herd her, cutting off escape routes, matching her turns, driving her away from other animals. The consortship can last days. It can last weeks. If she attempts to leave, the escalation is direct. Documented behaviors during herding include chasing, charging, biting, hitting her with the tail, and striking with the head. The rake marks left by dolphin teeth show up on the skin of herded females as parallel lines, and they heal into pale scars that stay readable for a long time afterward. The synchronized swimming, the years-long partnership, the coordination that looks like friendship from a boat. It exists in large part to solve the problem of holding a female who does not want to be held. That reframing alone would be enough. It isn't where it stops, because these alliances nest. In Shark Bay, first-order alliances of 2 or 3 males were found to belong to larger second-order alliances. Teams of teams, groups of up to roughly a dozen or more males who come to each other's aid. When one first-order alliance attempts to take a female from another, the second-order alliance is who shows up. And beyond that, researchers have described associations between second-order alliances as well. A third layer of cooperation between groups of groups. Sit with the architecture. An individual male has to know his 1 or 2 closest partners, the wider set of males who will back him, and the even wider set of alliances that his alliance is on good terms with, and simultaneously track which males are hostile, which alliances are currently strong, and who has recently defected. All of it stored in memory, all of it maintained through sound, in an animal whose face broadcasts nothing. This is a level of nested social organization that, outside of humans, has essentially no clear parallel. Not in chimpanzees, not in elephants, alliances within alliances within alliances, held together across decades by individuals who recognize each other by name. It is, by a wide margin, the most sophisticated social system yet described in a non-human animal. And the clearest thing it does is coerce. 2 clarifications before this hardens into something too simple. The first is that these alliances are not stable in a comfortable way. Relationships between males shift. Coalitions that cooperated in one season can be in conflict later. Males have been observed switching allegiance. The system has politics in the ordinary sense. Costs, benefits, betrayal, and the constant possibility that today's partner becomes tomorrow's problem. Which raises a question nobody can answer from a boat. What does an animal that never sleeps do with the knowledge that its closest ally might defect? We can describe the switching. We cannot describe the experience of it, and pretending otherwise would be exactly the error this whole story is about. The second clarification matters more. The females are not passive, and describing them as helpless gets the biology wrong. They evade. They flee, sometimes successfully. They appear to use their own long-term bonds with other females. And there is evidence that female associations and habitat choices function partly as ways of reducing exposure to male harassment. In some bottlenose populations, females spend significant time in shallow, complex water where a coordinated group of males cannot maneuver easily. That is a counter-strategy written into where an animal chooses to spend its life. It costs her the better feeding, and she pays it anyway. And the reproductive outcome is not simply decided by force. Female cetaceans have reproductive anatomy with complex internal structure, and one leading interpretation is that this gives females a degree of control over which male ultimately fathers a calf, even when they cannot control who is physically present. The arms race runs on both sides. It just runs invisibly on one of them, which leaves the honest summary of what Shark Bay showed. The most complex social intelligence documented outside our own species is not primarily organized around care or teaching or cooperative defense, though those exist. A very large share of it is organized around a contest between males over access to females, and a matching contest by females to retain control over the outcome. Both sides are running strategy. Both sides are keeping records. Neither side has a face that shows anything. Now for the consequence that connects this to everything after it. A female bottlenose dolphin's reproductive cycle is extraordinarily slow. Gestation runs around a year. The calf then nurses and stays with her for years afterward. In many populations, 3 to 6 years, sometimes longer. During that entire stretch, while she is nursing and raising, she is generally not available to conceive again. One calf is a commitment of half a decade. Run that through the logic of the alliance system. A male's reproductive opportunities are limited by how many females are actually cycling in the population at any moment. Every female with a dependent calf is, from his position, unavailable, and will be unavailable for years. The bottleneck isn't finding a female. It's finding one who isn't already occupied. You can see the shape of the problem from here. It's the kind of arithmetic that appears in other mammal societies too. And where it appears, so does something specific and ugly. The bodies of very young bottlenose calves had been washing up for a long time, and nobody thought the explanation was complicated. Then someone looked carefully at the wounds. The bodies had been coming ashore for years, very young bottlenose calves, some only weeks old, with damage that didn't look like drowning or disease. Broken ribs, torn lungs, deep bruising in the tissue, the kind of trauma that comes from being hit hard by something solid. On the outside, often, almost nothing. A few scratches, skin mostly intact. The explanation was obvious and everyone accepted it. Sharks or boats. Both are real threats, both kill dolphins regularly, and a calf is the most vulnerable animal in the water. Nobody was being lazy. That's genuinely what the evidence looked like from the outside of the body. The problem was that it stopped working the moment anyone opened one up. A shark bite is unmistakable. Teeth built for shearing leave curved wounds with serrated edges, and they remove tissue. Chunks missing, skin cut cleanly, the pattern of a jaw closing. Boat strikes leave their own signature. Propeller cuts arrive as a series of parallel gashes, often at regular spacing, and they slice rather than crush. The calves showed neither. What necropsies found instead was massive internal damage with very little external wound. Ribs snapped, in some cases in multiple places. Lungs ruptured. Livers torn. Tissue hemorrhaging under skin that was still unbroken. Injuries clustered on the sides and undersides of small bodies. This is blunt force trauma, the signature of something rigid driven into a body at speed, repeatedly, from beneath and from the side. And then there were the tooth rakes. Parallel lines in the skin, evenly spaced, matching the spacing of a bottlenose dolphin's conical teeth. Not bites taken out. Rake marks from a mouth that grips rather than cuts. You do not get that combination from a shark. You do not get it from a propeller. You get it from an animal with a long, reinforced beak, a set of gripping teeth, and enough acceleration to turn its own head into a battering ram, which describes with unpleasant precision an adult bottlenose dolphin. The finding has now been reported across multiple regions and multiple decades. Adult bottlenose dolphins kill bottlenose calves. In some cases, it's been directly observed rather than inferred. Adults ramming, tossing, and drowning young animals, sometimes over extended periods, occasionally by holding a calf underwater and preventing it from surfacing. Given what we established about voluntary breathing, that method is worth pausing on. There is no faster way to kill a dolphin than to stop it reaching the surface. And the killers are animals that understand the constraint from the inside. So the first reversal lands. The danger to a bottlenose calf is not mainly the shark, it's the species. Now the harder question, why? The leading explanation is the same one that explains infanticide in lions, langurs, and a long list of other mammals. Remember the arithmetic from the alliances. A female raising a calf is unavailable to conceive for years. Remove the calf, and that clock resets. If the killer is not the father, and if the female returns to a reproductive state sooner as a result, then the behavior pays. Not morally, arithmetically. It's a strategy that spreads because the animals that did it left more descendants than the animals that didn't, over a span of time that has no interest in whether any of this is acceptable to us. The evidence lines up with that reading in several ways. The victims are overwhelmingly very young, the age at which killing one has the biggest effect on the mother's availability. Where attackers have been identified, they are typically adult males. And in populations where these deaths have been documented, they can account for a substantial share of calf mortality. But the case is not closed. And this is where careful reading matters. The crucial link that a female whose calf is killed actually does conceive sooner with the male who killed it is extremely hard to establish in an animal that ranges over open water and lives for 40 years. In terrestrial mammals, that link has been demonstrated. In dolphins, it's largely inferred from the pattern rather than proven step by step. The people who study this are careful about the distinction, and it should stay that way. The interpretation is strong. It is not finished. There's a competing possibility that keeps circulating too, and it complicates things rather than clarifying them. That some of these attacks are aggression that isn't specifically reproductive at all. Dominance, redirected conflict, or something within the range of extreme rough behavior that happens to be lethal when the target is small enough. It's hard to separate from the outside. And keeping that ambiguity alive isn't hedging. It's the actual state of the science. There's also a counting problem underneath all of this that rarely gets said out loud. Every one of these cases exists because a body reached a beach and somebody with a scalpel got to it while it was still readable. A dolphin that dies in open water usually vanishes inside a day, scavenged and sunk. So the record of infanticide is not a measurement of how often it happens. It's a measurement of how often it happens close enough to land, in a place with people trained to look. Whatever the real number is, the one we have, is the floor. Now stay with the mother, because her side of this explains an enormous amount of dolphin behavior that gets read as tenderness. A bottlenose mother stays with her calf for years, commonly 3 to 6, sometimes longer. Through that whole period, the calf swims in a specific position beside her, in echelon, riding the pressure wave off her flank so it can keep up without exhausting itself. That's usually described as an adorable detail. It's a towing system that keeps a weak swimmer alive, and her vigilance is close to absolute, because it has to be. She isn't only watching for sharks, she's watching for adult males of her own species, and she cannot outfight a coordinated alliance. Where mothers with calves cluster in shallow, awkward, hard-to-maneuver water, that choice is doing real work. The same shallows that limit a shark's approach also limit a group of large males. In several populations, mothers with young calves have been found to use different habitat from the rest of the group entirely. That's not preference. That's evasion, sustained for years. Then there's the behavior that gets photographed and captioned wrongly more than any other. Female bottlenose dolphins have been observed repeatedly carrying dead calves, pushing the body along at the surface with the rostrum or the melon, keeping it up, staying with it. Some have done this for days, Some continue while the body decomposes visibly. They've been recorded diving to retrieve a corpse that sinks and bringing it back up. In some cases, other members of the group stay nearby while it happens, and the behavior costs her. Pushing a body through water is drag, and drag is energy in an animal that has none spare. This lands hard, and it should, but the reason it lands is worth being honest about. We do not know what a dolphin experiences during this. The behavior is real, documented across many cetacean species, and unmistakable. The internal state is not accessible. Calling it grief is an interpretation, and it's the interpretation that feels obvious to us because we are the animal that reads faces and projects. Some researchers do favor it. Others frame it more conservatively. A failure to update, a maternal response that has no off switch, a bond that persists because the machinery that maintains it doesn't have a mechanism for recognizing death. You are free to believe it's grief. Just notice that the evidence stops well short of the word, and that the dolphin's face, throughout all of it, has not moved once. Whatever is happening in there is happening behind bone that cannot show anything. Here's the shape of what we've now got. The most complex social system outside our own species includes coordinated coercion of females and lethal violence against infants of its own kind, carried out by animals that can recognize each other individually and remember each other for life. None of this makes them evil. That word doesn't survive contact with evolutionary biology. It makes them a mammal running a mammal strategy at a much higher level of coordination than most. And that framework, uncomfortable as it is, at least explains the killings. Reproductive competition explains infanticide. Alliance politics explains the herding. There's a logic to hold on to, which is exactly why the next thing breaks it. Because bottlenose dolphins also kill harbor porpoises, repeatedly in multiple parts of the world, with the same violence and the same injuries. Porpoises are a separate species. They are no reproductive threat whatsoever. Killing one resets nothing, gains nothing, opens no opportunity at all. And the dolphins don't eat them. A harbor porpoise is not a small dolphin. It's a different animal. Blunt-headed, no beak, shorter, thicker through the body, with spade-shaped teeth instead of cones. It's quiet where dolphins are loud, using narrow, high-frequency clicks that sit above the hearing range of the killer whales that hunt it. It avoids conflict. It doesn't gather in large numbers. It has no alliance system, no coordinated defense, nothing resembling the social architecture of the animals sharing its water. And in a growing number of coastal regions, harbor porpoises wash ashore killed by bottlenose dolphins. The injuries are the reason we know. Necropsies of stranded porpoises in these areas have found the same pattern that turned up in the calves: ribs broken in multiple places, lungs and livers torn, deep internal hemorrhaging, and skin often nearly intact over the top of it. Blunt force trauma delivered from beneath and from the side. Rake marks in parallel lines matching bottlenose tooth spacing. In some places, the attacks have been witnessed directly. Dolphins ramming a porpoise repeatedly, throwing it clear of the water, driving it down, working at it until it stops moving. Then they leave it. Nothing is eaten. Nothing is taken. The porpoise sinks or drifts, and the dolphins simply carry on with whatever they were doing. In areas where this has been studied over time, a substantial fraction of recovered porpoise carcasses show these injuries, enough that it isn't an anomaly. It's a recurring feature of how these two species interact in certain places, so the framework that worked a moment ago collapses. Infanticide had a currency: kill the calf, reset the mother's clock, gain reproductive access. There is no currency here. A porpoise is not a rival for mates. It cannot carry a dolphin's genes, and it cannot block them. Killing one changes nothing about who a male dolphin gets to breed with. The arithmetic that explained everything a moment ago now explains nothing. The obvious backup explanation is food, and it's the first thing anyone reaches for. 2 predators, 1 coastline, limited fish. Eliminate a competitor. It sounds tidy. It doesn't hold up cleanly. Dietary studies in several overlapping regions have found that bottlenose dolphins and harbor porpoises frequently take different prey at different depths, using different hunting styles. The overlap exists in places, but it's often modest. And competition-driven killing usually produces a specific pattern. Attacks concentrated where and when food is scarce, aimed at animals actively feeding. That's not consistently what's recorded. Porpoises get attacked in circumstances that have nothing obvious to do with a contested meal. There's a further problem. If the point were to remove a competitor, 1 killing per porpoise would do. What's been observed in some attacks is prolonged. Sustained assault continuing well past the point where the porpoise could pose any threat to anything, sometimes continuing on a body that has already stopped responding. So competition is on the table, but it does not carry the weight on its own, which leaves the field genuinely open. And the honest answer is that nobody has closed it. Here are the live hypotheses, and none of them should be presented as the answer. The first is misdirected infanticide. This one has real teeth, and it comes from the wound pattern. The injuries on killed porpoises and the injuries on killed dolphin calves are, in numerous cases, essentially indistinguishable. Same trauma, same distribution, same mechanism. And an adult harbor porpoise is roughly the size and shape of a dolphin calf, blunt, small, low profile, moving alone or in a pair. The suggestion is that a behavior evolved for one target is being triggered by something that resembles it, that the animal is running an infanticide program on the wrong species. If that's right, it's a strange kind of relief and a worse kind of unease at once. Relief, because it means there's no separate motive to explain. Unease, because it implies a lethal behavior that fires on the basis of size and shape rather than identity, in an animal that we've spent 3 chapters establishing can identify individuals by name and read the inside of a body with sound. That's an animal with the sensory equipment to know exactly what it's attacking. The second hypothesis is practice. Young males in particular have been implicated in some attacks, and the proposal is that this is fighting skill being developed on a target that can't fight back. Object practice. In the way that a young predator practices killing technique on something expendable, it's plausible. It's also close to unfalsifiable from a boat. And it has the uncomfortable property of explaining the behavior by making it more deliberate rather than less. The third is aggression as a social product. That in populations with intense male competition, a general readiness for violence exists, and the porpoise is simply the nearest available outlet. Redirected aggression is well documented in other social mammals. It fits the observation that porpoise killing seems more common in some populations than others, though the reasons for that geographic variation are not settled. The fourth is play, in the technical sense. Not fun. Play in the behavioral sense. Motor patterns performed outside their functional context, often in young animals, often repetitively. Dolphins are known to manipulate objects at length, pushing, tossing, carrying, retrieving. If a porpoise enters that behavioral category, then the sustained assault becomes something worse than an attack and stranger than a hunt. And the word most people would reach for at that point is one we need to talk about carefully. There's a detail in the porpoise's own equipment that makes this worse. Its clicks are narrowband and extremely high in frequency, and the working explanation is predator avoidance. The sound sits above where killer whales hear well. It's a stealth system, evolved against the thing most likely to eat it. But bottlenose hearing runs high too. Whatever the porpoise gains against orcas, it gains nothing against the animal that actually kills it in these bays. Its one defensive investment is pointed at the wrong predator. Notice what all 4 have in common. Every one of them describes the mechanism and stops short of the mind. That isn't cowardice. It's the wall. Because here is what we can actually see from the surface. We see a body moving. We see impacts. We see a porpoise die and a dolphin leave. What we cannot see is anything about intent, and no amount of high-definition footage fixes that because intent isn't a visible property. Everything we normally use to infer it in another animal, facial expression, vocal tone we can interpret, posture we recognize, is either absent or unreadable in a bottlenose dolphin. Its face cannot change. Its communication is in a channel we can record but not understand. The one animal whose behavior most urgently demands an explanation of motive is the one that gives us the least to work with. And so the interpretations pile up on top of the same set of broken ribs: practice, aggression, misfire, play, competition. 5 stories, 1 body, and no way to run the experiment that would separate them. There's one more thing that makes this harder rather than easier, and it belongs here because it's the piece people always miss. The same behavioral repertoire that produces these attacks also produces the events that made dolphins famous. There are credible documented cases of bottlenose dolphins pushing struggling swimmers toward shore, of dolphins circling people while sharks were in the area, of a dolphin bringing an object or an animal to the surface and holding it there. Those stories are the foundation of the entire friendly dolphin mythology. And the physical action in some of those cases, approach, contact, push, keep it at the surface, is not obviously different from the physical action in an attack, except in outcome. A dolphin pushing something upward is a dolphin pushing something upward. Sometimes the thing at the surface is a drowning human who lives. Sometimes it's a dead calf carried for 4 days. Sometimes it's a porpoise being thrown clear of the water before it's driven back under. We built a global reputation on one of those outcomes and quietly ignored the others. That's the real problem sitting under all of this. Not that dolphins are violent. Plenty of animals are violent. And violence in a social predator is not news. The problem is that we have an animal running behaviors we can describe in complete physical detail and cannot interpret at all. And we have spent 70 years confidently interpreting them anyway, in exactly one direction. Which raises the question that scientists studying this have to face every time a porpoise comes ashore, with its ribs caved in, and that they will not answer in public, for reasons that are much better than squeamishness. Is any of this cruelty? The word is sadism, and you will find it in headlines. You will find it in comment sections, in podcast episodes, in the captions under photographs of dead porpoises. What you will almost never find is a researcher using it in print about a dolphin. The easy read is that they're being cautious to protect a species people love, or that academia has a rule against saying anything vivid. Neither is right. The refusal is technical. Sadism is a claim about the inside of a mind, and there is currently no instrument, no method, and no experimental design that can reach it in an animal that cannot be asked. It's not that the answer is inconvenient, it's that the question, as posed, cannot be run. Picture the actual tool of the trade, a researcher on a small boat, long lens, notebook or tablet, watching a group for hours. What gets recorded is an ethogram, a fixed list of defined behaviors, each one written so tightly that 2 different observers watching the same animal will tick the same box. Approach, contact, ram, toss, chase, withdraw, duration in seconds, number of repetitions, identity of the animals involved, read off dorsal fin notches like fingerprints. That's the data. Columns of coded actions with timestamps. There is no column for enjoyment. There cannot be, because nobody has worked out what would go in it. This discipline came by that restriction the hard way. Late in the 19th century, the study of animal minds ran largely on anecdote. A naturalist would describe a clever dog or a scheming cat, and the story would enter the literature as evidence. It produced a great deal of confident nonsense. The correction came as a principle. Do not explain a behavior by a higher mental process if a simpler one accounts for it. Morgan's canon, and it has shaped the field ever since. Then came the horse, a German animal that could apparently do arithmetic, tapping out answers with a hoof in front of crowds and committees. It was investigated properly, and the finding is the one every behavioral scientist learns early. The horse was reading involuntary changes in the posture and breathing of the people watching, and stopping when they relaxed. Nobody had faked anything. The trainer believed it completely. That's the part that sticks. The failure wasn't fraud, it was competent people seeing what they expected in an animal that was doing something else entirely. So the rule has good reasons behind it. It also has a price, and the price is symmetrical in a way people rarely notice. The same restriction that blocks the word cruelty blocks the word grief. It blocks joy. It blocks love. When a mother carries her dead calf for 4 days, the researcher cannot write that she is mourning. Same wall, same reason. Nobody complains about that one. We accept the caution happily when it withholds a dark conclusion and resent it when it withholds a warm one, which tells you something about what we actually want from the science. Now, the specific problem with cruelty, because it's worse than the general one. Cruelty is not one internal fact. It's two, stacked. The animal has to recognize that the other is suffering, and that recognition has to be part of why the behavior continues. Remove either, and the word doesn't apply. A predator killing efficiently isn't cruel. An animal that has no capacity to register another state isn't cruel, whatever it does. You need awareness plus motivation, and you need both at once inside a skull you cannot open. Here's where it gets uncomfortable rather than reassuring. The first condition, could a dolphin know, is not the safe answer people assume. Go back to what its sense actually does. Sound passes through a body and returns information about the interior. In an attack at close range, the acoustic picture available to the attacker includes the victim's lungs, its skeleton, and the moment those things stop being intact. Ribs breaking are not an abstraction to an animal that reads interiors. Add the vocalizations. Harbor porpoises and dolphin calves both produce distress calls, and a bottlenose dolphin's hearing is exquisite in exactly that range. The claim that the attacker has no access to the victim's condition is not available. Something is being perceived in high resolution throughout. That doesn't establish cruelty. Perception is not motive. What it does is remove the comfortable version, the one where the animal is simply oblivious. Whatever else is true, this is not happening in the dark. Then there's the pattern that makes people reach for the word in the first place, and it's about repetition. Bottlenose dolphins manipulate objects constantly. They carry things, push things, toss things, retrieve them when they sink, and do it again. Sponges, seaweed, shells, bits of debris. Young animals in particular will work an object for extended periods with no functional payoff at all. It's classified as play. In the technical sense, motor patterns performed outside the context they evolved for. Now look at the physical shape of that behavior. Approach, grab or strike, lift, release, retrieve. Repeat. Now look at the physical shape of a porpoise attack. Approach, strike, lift clear of the water, release, return, repeat. They are the same sequence. That is the thing that unsettles researchers, and it's why the possibility keeps getting raised in the literature even though nobody will call it cruelty. There are documented cases of dolphins killing animals they never eat, and reports of fish being caught, tossed, torn apart, and abandoned. The killing does not stop when the target stops being a threat, and it does not stop when the target stops moving. In a hunt, that's inefficient. In object play, it's exactly what you'd expect because the behavior has never been about the outcome, which gives you two readings of the identical footage. One says a lethal program is misfiring on the wrong target. The other says the target is an object, and the animal is doing what it does with objects, and the fact that this one has lungs is not part of the calculation. Both explain everything visible. Neither can be tested against the other from a boat. And notice what the missing experiment would have to look like. To separate practice from play from misfire, you would need to control who meets whom, how often, and under what conditions with a dead animal as the readout. Nobody is going to run that, and nobody should. So the evidence will keep arriving the way it always has, opportunistically, from bodies after the fact. Here's the part that should reframe the whole argument. We can't prove cruelty in our own species without language. Every human case rests on testimony. What the person said, what they wrote, what they admitted. The physical evidence never gets you there on its own. A courtroom deciding whether an act was gratuitous is doing it through words, from the accused or from witnesses who can report what was said. Take language away, and human cruelty becomes unprovable too. It would just be bodies and mechanisms, and someone in a boat with a coding sheet, ticking boxes. Dolphins produce an enormous, structured stream of sound. They have names. They coordinate across nested alliances through acoustic channels alone. We record all of it, and we cannot read it. Whatever a dolphin might be broadcasting during an attack is sitting on hard drives in labs right now, fully preserved and completely opaque. So the wall isn't temporary. It isn't waiting on a better camera or a bigger data set. It's structural. A limit on what physical observation can ever deliver about a mind that doesn't share a language with the observer. That's the honest answer, and it satisfies nobody. We can describe the act down to the second. We cannot describe the intent, not now and quite possibly not ever, and a vacuum like that does not stay empty, because the public does not want an ethogram. It wants a verdict in one direction or the other, noble or monstrous, healer or killer. When the people who actually study the animal decline to supply one, the space gets filled by whoever will. It gets filled by aquarium marketing on one side and by viral horror on the other. And both are stories about us rather than reports about dolphins. Which is exactly how the strangest dolphin claim of the last 15 years went from a single sequence of television footage to something millions of people believe they know. A story about dolphins deliberately getting high, repeated so often that it now sits in the popular mind next to the smile and the rescue as settled fact. It isn't one. And tracing where it came from shows you precisely how the animal gets rebuilt in our image, even when the image is a dark one. You have heard this one. Dolphins hunt down pufferfish, pass them around the group like a joint, take a small dose of the toxin, and drift near the surface in a trance, staring at their own reflections. It's on countless lists of surprising animal facts. It's been repeated by newspapers, science channels, comedians, and probably by someone you know. Track it back, and it does not lead to a study. It leads to a television broadcast. The sequence aired in a nature documentary series, shot with camera systems, concealed inside models of marine animals. The footage shows young bottlenose dolphins handling a pufferfish, mouthing it gently, passing it between them, not eating it. That part is real. Cameras recorded it, and the behavior happened. Everything after that is interpretation, and the interpretation came from people speaking to the press around the broadcast, not from a paper. The claim was that the dolphins were deliberately extracting a small dose of toxin for a narcotic effect. It traveled instantly because it's a fantastic story. And in the years since, it is since, It has hardened into something people state as established fact. There is no published, peer-reviewed research demonstrating that dolphins intoxicate themselves with pufferfish. Not a rejected study, not a contested one. The work simply hasn't been done. What exists is footage plus a hypothesis offered in interviews. Now look at what the hypothesis actually requires, because this is where it gets shaky in a way that's more interesting than the story itself. The toxin in a pufferfish is tetrodotoxin, and it is not a psychoactive drug in any ordinary sense. It's a sodium channel blocker. It works by stopping nerve signals from firing. That's the entire mechanism. It doesn't alter mood or perception. It shuts down the electrical conduction that muscles depend on. In humans, poisoning produces numbness, then progressive paralysis, and death comes when the muscles that drive breathing stop working. Crucially, victims can remain conscious throughout. There is no euphoria in the clinical literature. There's a body that stops responding. Apply that to a dolphin. This is an animal that must consciously decide to breathe and must physically swim to the surface to do it. A compound whose main effect is paralyzing the respiratory system is, for this species specifically, close to the worst possible thing to put in your mouth. A dose large enough to produce a noticeable neurological effect would be flirting with the dose that stops you reaching air. Land mammals can afford a stumble. A dolphin cannot afford a lapse. So the popular version proposes that an animal with no automatic breathing has evolved a recreational habit built around a paralytic. That's not impossible. Biology produces stranger things. But it's a very large claim resting on no measurement whatsoever. Nobody has sampled the blood of these dolphins. Nobody has established a dose. Nobody has demonstrated that any toxin crossed into the animal at all. And there are simpler readings of the same footage. The animals in the sequence were young. Juvenile bottlenose dolphins handle objects constantly. Sponges, seaweed, shells, debris, anything they can carry. Object play is one of the best documented behaviors in the species. A pufferfish that inflates into a rigid, spiny ball is an unusually good toy. It changes shape when handled. It stays buoyant. It responds. Passing an interesting object around a group is ordinary dolphin behavior, thoroughly recorded with objects that have no chemistry to them at all. There's also a boring possibility that gets ignored. A dolphin mouthing something noxious may be doing what any animal does with something noxious: testing it, then not swallowing it. The behavior looks careful because swallowing it would be a mistake. Which explanation is correct? Unknown. The honest position is that the behavior is real, the intoxication is unverified, and the alternatives haven't been ruled out either. That's the answer, and it's the answer nobody shares. Here's what makes this worth stopping on instead of skipping past. Notice what the pufferfish story does. It takes a dolphin and makes it relatable in a new register, not the noble healer the story culture had grown bored of, but the party animal. The clever teenager sneaking a substance. It's still a person in a dolphin suit. It's just a different person. That's the pattern this whole story has been circling. Every version of the dolphin we've built has been an image of ourselves, adjusted to fit whatever we needed at the time. The rescue stories came first, and they were real events wrapped in a very selective reading. Dolphins have been documented, pushing struggling swimmers toward shore. Also documented, dolphins pushing dead calves, floating debris, and porpoises they had just killed. The physical behavior of lifting something to the surface is the same behavior every time. We selected the outcomes that flattered us and built a global reputation out of a subset. Then came the middle of the 20th century, which is where the modern myth was manufactured with unusual precision. A television series about a bottlenose dolphin who rescued people every week put the image in front of a generation. Marine parks arrived and sold the same story as an experience. And a strand of research at the time proposed that dolphins were on the verge of language and possibly comparable to human intelligence, an idea that captured enormous public attention and was later heavily criticized on methodological grounds. The reasonable core, that these are large-brained social animals with complex communication, survived. The extravagant version did not, but it had already escaped into the culture and it never came back. And there's a version of the animal from that same period that almost never comes up, even though it's the least mythological of all of them. While the television dolphin was rescuing children every week, actual bottlenose dolphins were being trained by the United States Navy. The program started in the early 60s. It still exists. And its animals have been trained to locate sea mines on the seafloor and to find and mark objects lost in deep water. The reason a defense program wanted them is exactly what this story keeps describing: a sonar that reads the inside of things in murky water better than anything anyone has built. For years, the details were classified, and into that silence went the obvious rumor that the animals were being trained to kill divers. The Navy has denied it. What isn't in dispute is the judgment underneath the program. Somebody looked at this animal, ignored the smile completely, and treated it as the best available sensor. And it worked, which is the least surprising sentence in this whole story, because everything so far points straight at it. A sense that resolves the interior of objects, in water where cameras are useless, attached to an animal that can be taught a task in a handful of sessions and will hold it for years. Strip the mythology off in either direction, and what's left is a piece of biology effective enough that a Navy built a unit around it. None of these versions contradict each other, because none of them were ever really about dolphins. Then, the reversal. As dolphin violence became better documented, the story flipped, and headlines started delivering the opposite verdict with equal certainty. Rapists, murderers, sadists, same animal, same evidence, opposite conclusion, identical confidence. And both directions do the same damage. The friendly version made a coercive, occasionally lethal predator into a mascot. The monstrous version imports human moral categories into an animal that has no equivalent of them. Neither is a description. Both are mirrors. The pufferfish story is the tell, because it's neither noble nor monstrous. It's just fun. And it spread faster than either. It reveals that what we're doing isn't really about judging dolphins at all. It's about needing them to be a version of us in whatever mood the culture is currently in. Meanwhile, the actual animal has been sitting there the entire time, doing something far more interesting than any of it. Because while the argument ran about whether dolphins were angels, murderers, or stoners, the field was quietly documenting what that permanently running brain is genuinely for. Not moral reasoning, not recreation. Something that shows up as physical, repeatable, measurable behavior. And that varies from bay to bay in a way biology alone cannot explain. In one population, dolphins tear sponges from the seafloor and wear them over their beaks. 2 bays away, nobody does it, and the water is the same. In one estuary, dolphins drive fish onto a mud bank and go up the slope after them, out of the water entirely, timed to the second. A few hundred kilometers along the coast, nobody has ever tried it. Techniques that exist here and not there, passed from mother to offspring, refined across generations, sometimes lost when the individuals holding them die. That's not instinct. Instinct doesn't have a postcode. That's the cleanest test in the whole field, and it's the one that finally tells you what all that permanently running brain is actually for. The logic is simple. If a behavior is written into the genes, it shows up wherever the genes do. Bottlenose dolphins in one bay and bottlenose dolphins in the next bay are the same species, often with animals moving between them, facing the same water, the same seafloor, the same fish, So if a hunting technique exists in one group and is completely absent from the group a few kilometers away, and if it runs down family lines instead of spreading evenly through the population, then you are not watching a body do what bodies do. You are watching information move between minds. Start with the sponges, because it's the clearest case anyone has. In Shark Bay, a subset of dolphins dive to the seafloor, tear a conical marine sponge loose, and fit it over the beak like a glove. Then they work the bottom with it, driving the covered rostrum through rubble and sediment, flushing out prey that lives buried down there. Every part of that has a reason, and the reason connects back to something we established earlier. Remember what makes a fish loud to a dolphin? The swim bladder. That gas-filled sac is the brightest thing in a fish's body, the internal lantern that echolocation reads from a distance. Now think about a fish that doesn't have one, sitting motionless inside sediment. Acoustically, it is close to nothing. A dolphin's greatest sense, the penetrating interior-reading sonar that makes it such a formidable hunter in open water, goes quiet exactly there. That's a blind spot, and the blind spot contains food that almost nobody else is taking. The problem is the seafloor itself. Broken shell, rock, spines, driving your face into that repeatedly day after day, on the same rostrum that carries your hearing apparatus and your entire sensory front end, is a serious injury risk. So the sponge solves the second problem, created by solving the first. Protection on the beak turns an unreachable food supply into a reachable one. Then comes the part that made this famous. Genetic work on the sponge users found that they trace back overwhelmingly through the female line, mothers to daughters, generation after generation. It isn't a random skill picked up by whoever happens to find a sponge. It runs in families. Calves who sponge have mothers who sponge, and they spend years alongside her while she does it. The best supported interpretation is that the technique is learned, not inherited, and it stands as one of the strongest cases for material culture in any marine mammal. And it costs. Spongers dive deeper, forage longer, and spend noticeably more time alone than other dolphins in the same bay. In a species where social bonds are the entire operating system, that's a real price. They've traded company for a private food supply nobody else can reach. Now cross the planet and look at a completely different solution. Along parts of the southeastern United States, small groups of bottlenose dolphins hunt fish by driving them out of the water entirely. They work in coordination, pushing a school toward a shallow mud bank, then charging as a unit and forcing a wave up the slope. The fish get stranded on the mud, and the dolphins go with them, hurling their own bodies out of the water onto land, grabbing the fish, and thrashing back into the channel. Watch that with cold eyes for a second. This is an air-breathing animal that cannot support its own weight out of water, deliberately beaching itself. If the timing is wrong, if the tide is wrong, if the slope is wrong, it doesn't get back. Every single attempt is a controlled version of the thing that kills dolphins, and the technique carries a signature you can read off the body. Strand-feeding dolphins in these populations tend to do it on the same side almost every time, right side down, again and again for a whole life. The result is asymmetric wear on the teeth and abrasion on that flank. The animal is physically shaped by a behavior that has to be learned, practiced, and survived. Calves don't get it immediately. They watch, they attempt it badly, and it takes years of practice alongside the mother before the timing works, which means the technique requires exactly the long dependency period we've already talked about, the 3 to 6 year stretch a calf spends glued to its mother's flank, the same stretch that makes her a target for males and makes her calf a target for infanticide. The vulnerability and the knowledge come from the same source. You cannot have one without the other. Elsewhere, the same species facing the same problem has never tried it. Not badly. Not at all. In parts of Florida, a different trick shows up. One dolphin swims a tight circle over a shallow bottom, beating its tail to throw up a ring of mud. The plume rises into a wall the fish will not cross. Trapped inside a fence made of water and silt, they panic and do the only thing available: jump. And they jump outward, over the ring, into the open mouths of dolphins waiting on the outside, positioned in advance, facing inward. That requires the ringmaker and the catchers to be running the same plan at the same time, with the payoff arriving only for the ones who guessed correctly where the fish would exit. It's localized. It's not something all bottlenose dolphins do. And then there's the arrangement that should not be possible. In southern Brazil, at Laguna, in Santa Catarina, a group of bottlenose dolphins hunts mullet in cooperation with human net fishermen. The water is murky enough that the men standing waist-deep can't see the fish. The dolphins drive the school toward shore and then produce a distinctive, abrupt movement, a sudden dive, a particular roll at the surface, which the fishermen have learned to read as the moment to throw. The nets go in. The school scatters. The dolphins take the fish that break formation. Both sides benefit, and both sides had to learn it. Not every dolphin in that water participates, and not every fisherman works with them. The knowledge exists in a subset of each population, and it's passed down within each, dolphin to dolphin, fisherman to fisherman, across generations, in an interaction that has been running for well over a century. Two different species, no shared language, no shared biology, running a coordinated hunt on a signal that had to be invented and then taught, on both sides. And nobody on shore administers it. The fishermen learn to read the dolphins. The dolphins learn to read the fishermen. Neither side has any way to explain the arrangement to a newcomer, except by standing in the water and doing it until they get it. Now put the whole collection side by side and see what it adds up to. The techniques are not variations on one instinct. They're genuinely different solutions to genuinely different local problems. A sensory blind spot, a shallow mud bank, a murky estuary, a human with a net. Each one exists in a specific place, in specific families, and is absent a short distance away. That's not what a species does. That's what a set of cultures does, which gives you the answer to the question that's been hanging since the beginning. What is the permanently running brain for? Not tricks, not moral reasoning. It's for holding, updating, and transmitting a body of local knowledge. Who everyone is, where the food is, which technique works in this water, and how to teach it to something that will take 5 years to learn. And that knowledge is fragile in a way instinct never is. Instinct can't be forgotten. Culture can. When the animals holding a technique die without passing it on, it doesn't degrade slowly. It disappears. A behavior built over generations can be erased inside one. And here is what that costs. Further down this story. If the knowledge is local, populations are not interchangeable. Lose the animals in one bay, and you don't lose a fraction of a species. You lose a technique that existed nowhere else, held by a few dozen individuals, built over generations, that neighbors who never learned it cannot simply pick up. The species survives. The method doesn't. Nothing in the water writes it down. Which brings us to the thing nobody mentions about culture. It only works if the animals live long enough to teach it. Decades of overlapping generations, 5-year apprenticeships, knowledge handed down through mothers who survive long enough to hand it down. That means the entire system depends on keeping a very expensive body running, without pause, in cold water, for 40 or 50 years. And that body is the least forgiving part of this whole animal. Put a human being in water at the temperature dolphins live in year-round and start a clock. In many of those waters, you have hours before your core temperature drops far enough to kill you. And long before that, your hands stop working and your judgment goes. Water strips heat out of a body many times faster than air at the same temperature. That's not a detail. That's the single biggest bill this animal has to pay, every second of every day, for 50 years, with no option to stop paying it. A dolphin is a mammal. It runs at roughly the body temperature you do, and it does that while permanently submerged in a fluid that is constantly pulling that heat away. In an environment with no shelter, no fire, no burrow, and nowhere to go when the water gets cold. There is no version of a dolphin's life that includes warming up, so the entire body has been rebuilt around the problem, and every solution creates a new one. The first is blubber, and it is not fat in the way you're picturing fat. It's a dense layer of fibrous tissue laced through with collagen, wrapped around the whole animal, like a hull. It insulates. It also stores energy, adds buoyancy, and, because it's structural rather than loose, helps hold the smooth, hydrodynamic shape that makes the animal cheap to move through water. One tissue, four jobs. But insulation has a fatal flaw for a warm-blooded animal that swims hard. Wrap yourself in a perfect thermal barrier and then work your muscles at speed, and you cook. The heat has nowhere to go. A dolphin sprinting after fish generates a serious thermal load inside a body specifically designed not to let heat escape. The solution is the parts that stick out. The dorsal fin, the flippers, and the flukes have almost no blubber. They're thin, blood-supplied, and in direct contact with the water. When the animal overheats, blood flow to those surfaces opens up and heat dumps straight out. When it needs to conserve, flow shuts down, and the plumbing there is genuinely elegant. In the flippers and flukes, arteries carrying warm blood outward are surrounded by veins carrying cold blood back in, packed tightly together. Heat crosses from the outgoing blood to the returning blood before it ever reaches the skin. The warmth gets recycled inside the body instead of being handed to the ocean. Countercurrent exchange, the same principle that keeps a duck's feet from freezing, running at a much higher stake. Then there's the use of that system that nobody expects. A male dolphin's testes are internal. They have to be. There's no scrotum on a streamlined body, and a dangling structure would wreck the hydrodynamics. But sperm production in mammals needs to run cooler than core body temperature, which is exactly the reason your own anatomy is arranged the way it is. So a dolphin has a problem. Heat-sensitive tissue locked inside a heavily insulated core. The fix is a vascular network that takes cooled blood returning from the dorsal fin and the flukes and routes it past the reproductive tissue on the way through. The same heat-dumping surfaces that stop the animal overheating during a chase are also being used as a cooling circuit for the testes. A thermal management system built for one problem got wired into a second one. Now the running costs, because insulation only reduces the loss. It doesn't stop it. A dolphin is burning fuel continuously to hold its temperature against a fluid that never stops taking it. Add the cost of swimming, add the cost of hunting, add the cost of maintaining that oversized brain. Nervous tissue is metabolically expensive in every animal that has it, and this one is running a large, densely folded cortex around the clock without a full shutdown. The energy demand of a bottlenose dolphin is high, and it is relentless, which means fasting is barely an option. Think about what that removes. A bear can eat heavily and then sleep through the lean months. A snake can go weeks between meals. A lion can gorge and then do very little for days. Those strategies exist because the animals can lower the bill. A dolphin cannot lower the bill. The ocean is still pulling heat out of it at the same rate whether it ate this morning or not. Every day it has to find enough fish to cover the thermal cost of being a warm animal in cold water, plus everything else. That reframes the hunting completely. The sponges, the mud rings, the strand feeding, the arrangement with the fishermen. None of that is enrichment. It's not cleverness for its own sake. It's a species with a very high fixed cost, in an environment where prey is patchy and mobile, inventing whatever it takes to keep the intake above the outflow. The culture exists because the metabolism demands it. And there's a second bill running underneath, one almost nobody thinks about. A dolphin lives surrounded by water it cannot drink. Seawater is saltier than mammal blood. Swallowing it costs more water to excrete than it delivers. So the animal gets its water from its food, from the fish themselves, and from the chemistry of breaking down fat and protein. Cetacean kidneys are built for the job, divided into many small units in a way that reflects how hard that filtration work is. The whole arrangement means that food isn't just calories for a dolphin, it's the water supply too. Go hungry, and you don't just get weak, you start to dehydrate in the middle of an ocean. Then the skin, which is the strangest maintenance cost of all. Drag is the enemy of an animal that has to swim constantly. Anything rough on the surface, barnacles, algae, fouling of the kind that grows on every hull and every slow-moving object in the sea, costs energy on every stroke for life. A dolphin's answer is to refuse to give anything time to attach. The outer layer of skin is shed and replaced on a time scale of hours rather than the weeks a human takes. The whole surface is continuously flaking away and being rebuilt from underneath, which is why dolphin skin looks and feels the way it does. Smooth, slick, almost artificial to the touch. Behind that smoothness is a cell production line running permanently and running on the same energy budget as everything else. The animal is paying continuously just to stay slippery. Now stack the whole system and look at what it means when something goes wrong. An injury on a dolphin is not just an injury. It's a hole in the thermal envelope, a break in the drag-free surface, an infection risk in water full of bacteria, and a metabolic debt. Because healing costs energy, and the energy has to come from the same intake that was already fully committed to staying warm and staying fed. A wounded dolphin has higher costs and, usually, reduced ability to hunt. Those two things move in the wrong directions at once, and it cannot rest to recover. It still has to swim. It still has to surface and consciously breathe. Half its brain still cannot sleep. There is no convalescence in this animal's life, no equivalent of lying down until it passes, which finally explains something that's been sitting in the background of this whole story. We've been describing behavior that looks harsh, the coercion, the killing of calves, the relentlessness, the refusal to let a target go. It's tempting to read that as temperament, as though these animals are simply aggressive by nature. Look at the machine instead, a body that cannot stop generating heat loss, cannot stop moving, cannot fast, cannot rest, cannot drink, and cannot afford a serious injury, running for 4 or 5 decades in an environment that offers no shelter and no guarantees. Intensity isn't a personality trait here. It's what the physics requires. An animal that could afford to be casual would already be dead. That's the reframe. Relentlessness is mandatory. And here's where the whole picture tightens, because everything we've built so far, the never-sleeping brain, the penetrating sonar, the nested alliances, the inherited hunting culture, the machine burning through its budget every hour, all of it describes an animal that sounds untouchable. A top predator with the most sophisticated social system outside our own species. It isn't untouchable, not close. Pull a bottlenose dolphin out of the water in many coastal populations and look at its flanks, and you find pale crescent-shaped scars, sometimes several, sometimes overlapping. The tissue healed into permanent marks. They're not from other dolphins. The spacing is wrong, the shape is wrong, and the curve tells you exactly what closed around that body. The apex predator has bite marks on it. Look at enough dolphins in the right places and a pattern starts showing up on the skin. Pale crescents on the flank, sometimes a clean arc of tooth punctures, sometimes a section of the body where the outline itself is wrong, a chunk taken out of the trailing edge of a fluke, a notch missing from a dorsal fin, tissue that healed into a permanent deformation. These are not rake marks. Rake marks are parallel lines from conical teeth, and we've already met those. This is different geometry entirely. A curved row of punctures, or an arc of missing tissue left by a jaw built for shearing rather than gripping. In multiple coastal populations that have been surveyed carefully, a meaningful share of adult bottlenose dolphins carry these marks. In some places, the figure is high enough that carrying a shark scar is unremarkable, a normal feature of an adult body, like gray hair. It's worth knowing how anyone can say that with confidence, because the method is unglamorous, and it sits underneath everything in this story. Dolphins are identified by their dorsal fins. The trailing edge collects nicks, notches, and tears over a lifetime, and the resulting outline is distinctive enough to work like a fingerprint. Researchers photograph fins, match them against catalogs that in some places now run back decades, and build a record of who was seen, where, alongside whom, and in what condition. That's how the alliances were mapped. That's how mothers and calves were followed across years. And it's how scar frequency gets counted, not by catching anything, but by photographing the same animals over and over until the pattern of damage across a population becomes visible, which also means the record stops at the waterline. A fin above the surface tells you the animal is alive and roughly what shape its back is in. It tells you nothing about what's happening underneath, and nothing at all about the animals that simply stopped appearing in the catalog. And here's what those scars actually represent, which is the part people get backwards. Every one of them is a survival. A healed wound means the animal got away. The dolphins carrying shark bites are the successes. The failures don't wash up carrying evidence because they don't wash up. In the ocean, a dead dolphin usually disappears completely. Consumed, scavenged, sunk. So the scar frequency you can measure on living animals is not a measure of how often sharks attack dolphins. It's a measure of how often sharks attack dolphins and fail. The real rate is higher than the skin can ever tell you. Nobody knows by how much, and that uncertainty is permanent, because the missing data is the part that got eaten and never came back. The predators involved are the large coastal sharks, tiger sharks in warm waters, bull sharks in shallow and estuarine systems, white sharks in cooler ones. A big tiger shark is longer than a bottlenose dolphin and considerably heavier, with teeth serrated on both edges that are built specifically to cut through dense tissue and bone. A dolphin's blubber layer, the thing that keeps it alive thermally, is not armor against that. It's meat. So how does a dolphin survive against something like that? The answer is not what most people assume. The fighting back story is real, but it's the exception, not the strategy. Dolphins have been observed harassing and ramming sharks, and a group of coordinated adults driving a rostrum into a shark's gills or belly is a genuine threat. That footage exists, and it's dramatic. It's also not something anyone should extrapolate from. A single dolphin against a large shark is not a fair fight, and there is no reliable evidence that dolphins routinely win these encounters. The dead ones aren't available to correct the record. The actual defense is earlier and quieter, and it costs far more than a fight would. It's avoidance, and you can see it written into how entire populations use their habitat. In areas with heavy shark presence, dolphins, especially mothers with calves, shift into shallow water, very shallow, sometimes barely deeper than the animal itself. In shallows, a large shark loses its main advantage, the ability to come up from below, out of the dark, into a body that can't see it coming. Take away the vertical approach, and a shark becomes far less dangerous. But look at what the shallows cost. The best feeding is often not in the shallows. In systems where this has been studied, the deeper, richer foraging grounds are also the highest risk areas, and dolphins in those systems make a trade. Using safer, poorer habitat when predation risk is high, and moving into the productive water when it drops, often shifting with the seasons as shark numbers change. In the most direct terms, they go hungry to stay alive. Now put that next to the metabolic bill and feel the squeeze. This is an animal that cannot postpone its costs, that cannot fast, that has to keep intake above outflow every single day. And the response to sharks is to voluntarily hunt in worse water. Two lethal pressures pointing in opposite directions, and the animal has to sit between them for its entire life. There's another cost, and it's paid at night. Remember what sleep looks like for a dolphin. One hemisphere down, one eye open, the animal drifting near the surface. That resting posture is the most exposed an adult dolphin ever is. Slow, at the surface, half-conscious. It's also when the largest coastal sharks are most active. Whatever the specific arrangement in any given population, resting for a dolphin is not safety. It's the moment of maximum vulnerability, and it has to happen every day for 50 years, which means the never-sleeping brain isn't only an air-breathing adaptation. Half of that animal stays awake in water that contains things which eat dolphins, and the eye that stays open is pointed at a real problem. And now the reframe this has been building toward. Go back to the male alliances. 2 or 3 animals moving in tight synchrony, coordinating over years, backed by a wider network that arrives when there's trouble. We looked at that and saw coercion. And the coercion is real, but an alliance is also a defensive unit. Multiple adults in coordinated formation is precisely what a large shark cannot easily handle. Too many angles, too many bodies, no isolated target. The mother who keeps her calf pinned to her flank, in echelon, in shallow water, is doing something that looks like devotion and is also a survival protocol against something with serrated teeth. That doesn't excuse anything. The infanticide is still infanticide, and the herding is still herding, but it changes the texture of the picture. These animals didn't build an intense, hyper-coordinated, permanently vigilant social system in a world that was gentle to them. They built it while being hunted. The same behaviors are doing several jobs at once, and separating which pressure produced which piece is genuinely difficult. There's one more thing that belongs here, because it's the ugliest arithmetic of all. Calves are the primary target. A young dolphin is small, weak, an inefficient swimmer, and unable to keep up in a hard evasion. A shark doesn't have to beat the group. It needs one small animal at the edge of it, for a few seconds once. And unlike the dolphins, it doesn't have to breathe, doesn't have to surface, and never has to stop. Sharks take them. Adult dolphins kill them. Boats strike them. In many bottlenose populations, a substantial proportion of calves do not survive their first year. So a female invests a year of gestation and then years of intensive care into an animal that is being hunted from several directions simultaneously, by another species from below and by her own species from the side. She spends much of her adult life producing offspring that mostly do not make it, in a system where the reproductive competition around her is itself one of the threats. That is the population running its normal, unremarkable operating conditions. Nothing has gone wrong in that description. That's baseline. And it's the reason the next thing hits so hard. Everything so far leaves a mark. A shark bite scars, a ram breaks ribs, a boat strike cuts. All of it is visible, countable, recorded on the body by anyone who bothers to look. But the die-offs that have killed bottlenose dolphins in the largest numbers leave nothing on the outside at all. No bites, no fractures, no propeller cuts. Just animals arriving on beaches over and over for months, in numbers no shark population could produce. Something else is moving through them, And the thing that makes it so effective is the same thing that made them successful in the first place. The bodies come ashore over months, not days. That's the first thing that separates this from anything else in the story. A shark attack produces one animal. A boat strike produces one animal. What we're looking at now produces a coastline where strandings keep arriving week after week until the people responding cannot keep up with the volume. And the animals show nothing on the outside. No bites, no fractures, no cuts. What they show is emaciation, bodies that have burned through their blubber, along with damage in the lungs, and in some cases lesions in the brain. Animals that were disoriented before they died. The cause is a virus. Cetacean morbillivirus belongs to the same family as measles in humans and canine distemper in dogs, and it does to a dolphin roughly what those pathogens do to their own hosts. It attacks the respiratory system and the nervous system, and, this is the part that matters most, it suppresses the immune system while doing it. That last property is what makes it lethal at scale. A dolphin with morbillivirus often doesn't die of morbillivirus in any direct sense. It dies of everything else. With its immune defenses knocked down, infections that a healthy animal would clear without trouble take hold. Bacterial pneumonia, fungal infections, parasites that were already present and previously controlled. The virus doesn't kill the animal so much as it opens the door and lets the ocean in. Major outbreaks have hit bottlenose dolphin populations along the western Atlantic more than once in recent decades, with mortality events severe enough to be declared unusual by the agencies that track them, and strandings running into the hundreds along affected coastlines. In some outbreaks, mass die-offs progressed along the coast over time, as though the thing were traveling. It was, and the way it traveled is the reversal here. Go back to what we've established about these animals. They live in a fission-fusion society, groups forming, dissolving, reforming with different members constantly. An individual might associate with dozens of different animals in a week. They travel long distances. Populations that seem separate on a map turn out to be connected by individuals moving between them. They maintain physical contact routinely, bodies touching, flippers stroking, animals surfacing together in tight formation. They breathe explosively at the surface, in the same air, within a meter of each other. Now design a transmission system for a respiratory virus. You would design that. Every single feature that makes bottlenose dolphins the most socially sophisticated animal in the ocean is also a feature that moves a pathogen efficiently through a population. The wide-ranging contacts, the mixing between groups, the physical closeness, the shared surface air. Their intelligence is built on connectivity, and connectivity is exactly what an epidemic runs on. That's the trap at the center of this. The social architecture cannot be switched off. A dolphin cannot isolate. Its hunting depends on coordination. Its calves depend on the mother's constant presence. Its defense against sharks depends on being in a group. And its knowledge, the culture, depends on animals spending years in close contact with each other. Distance would kill them slower, but it would still kill them. There is no version of a healthy dolphin life that reduces contact. And there's a second layer to this that's worse, because it's about the mothers. A morbillivirus outbreak doesn't only kill the animals it infects, survivors carry immunity, and mothers pass antibodies to their calves through milk, which means a calf born to an exposed female gets some protection. But that protection is temporary, and it depends on the mother having survived a previous exposure. After an outbreak sweeps through, the population left behind is largely immune. And then, over the following years, a new generation grows up that has never encountered the virus at all, which sets the clock for the next one. The virus doesn't need to change. It just needs to wait until enough non-immune animals accumulate. That's why these events recur rather than resolving. The population's own reproductive cycle rebuilds the fuel. Now the part that connects this to us. Morbillivirus is a marine pathogen, but it is not the only thing infecting these animals, and some of what's reaching them did not come from the ocean. Bottlenose dolphins in coastal waters live in exactly the places where terrestrial runoff arrives. River mouths, estuaries, bays, fed by agricultural land, livestock operations, and urban drainage. Rain moves material off the land and into the shallows, and it carries pathogens with it. Toxoplasma gondii, a parasite whose life cycle runs through cats and which is shed in their feces, has been identified in stranded marine mammals, along with other organisms whose reservoirs are on land rather than in the sea. Freshwater runoff has also been linked to skin disease in dolphins in estuarine systems, where salinity drops after heavy rain. Rain is the delivery event. Whatever has been accumulating on the land arrives at the coast in a pulse, in exactly the weeks when the water turns fresh and the dolphins are still sitting where they always sit. So the boundary you probably imagine between land and ocean, a coastline, a clean edge, is not real from a pathogen's point of view. It's a permeable membrane, and it runs one way. Whatever accumulates on land eventually reaches the animals living immediately offshore. That gives you the shape of the threat. This is a species with no medical intervention available to it, no capacity to isolate, no ability to rest while sick, and a metabolism that cannot be dialed down during illness. A dolphin cannot fast, cannot stop swimming, cannot stop consciously breathing, and cannot heal without a surplus it may not have. Now infect it with something that attacks the lungs and suppresses its immune system, in an animal that must physically choose to breathe. An emaciated, stranded dolphin is the end state of that arithmetic. It stopped being able to hunt effectively. The intake dropped below the outflow. The body consumed its own blubber, which is also its insulation, which accelerates heat loss, which raises the bill further. That's a spiral with no bottom. And by the time an animal comes ashore, it has usually been running down it for a long time. And the strangest cruelty in this is what happens socially. Dolphins have been observed supporting sick or dying individuals at the surface, staying with them, pushing them upward. Whatever that behavior means internally, and we've been careful about that word all the way through, the physical effect is that healthy animals gather around an infected one and remain in close contact with it. The behavior that keeps a struggling animal breathing is also the behavior that most efficiently exposes everyone nearby. And a stranding is not a quiet ending, which is worth saying plainly because the photographs never show it. Out of water, a dolphin's body turns on it immediately. The weight it was never built to support presses down on its own organs. The blubber that keeps it alive in cold water traps heat with nowhere to dump it. The skin that has to stay wet begins to dry and split. An animal that comes ashore alive is being crushed and overheated by the same equipment that was keeping it functioning an hour earlier at sea. That's what a response team is actually racing, not the illness. The physics of a marine mammal lying on sand. So here's where we've arrived. The apex predator with the most complex society outside our own species is being killed in the largest numbers by something with no teeth, using the species' own greatest strength as its delivery system. The connectivity that builds the culture spreads the pathogen. The closeness that protects the sick infects the healthy. Every strength has a matching cost, and the costs arrive together. But disease at least has an obvious mechanism. A virus infects, replicates, spreads, kills. You can trace it. You can watch it move along a coast. You can count the bodies. What's been found inside those bodies is harder to look at because it doesn't come from another organism at all. When stranded dolphins are examined, tissue samples get taken and analyzed. and the concentrations of industrial chemicals recovered from the blubber of coastal bottlenose dolphins. Compounds banned in much of the world decades ago, that were never meant to be in any living thing, are among the highest measured in any animal on the planet. They didn't eat those chemicals directly. They inherited them from every fish they ever caught, concentrated upward through the food web until they arrived in the body of the thing at the top, which raises the question that makes this the most disturbing part of the whole story. What does a mother do with a lifetime of accumulated poison when she has a calf? Start with the physics of the problem because it explains everything that follows. Certain industrial compounds are fat-soluble and chemically stable. Polychlorinated biphenyls, PCBs, are the clearest example. They were manufactured in enormous quantities through the middle of the 20th century for electrical equipment, coolants, and industrial fluids. And they were valued precisely because they don't break down easily. That stability is why they were useful. It's also why they are still here. Fat-soluble means a compound doesn't dissolve in water and doesn't get excreted efficiently. It means the molecule finds fat and stays there. So when a PCB molecule enters a living thing, it doesn't pass through, it lodges. Now run that upward through a food web. Plankton takes up a trace amount from the water. A small fish eats a great many plankton over its life, and it keeps the contamination from all of them. A larger fish eats a great many small fish and keeps everything they were carrying. Each step concentrates what the step below it accumulated. By the time you reach the top of a marine food chain, the load isn't a trace anymore. It's the sum of thousands of lives compressed into one body. A bottlenose dolphin sits at or near the top. It eats large quantities of fish every day for decades because, as we've established, it cannot afford not to. The metabolic bill that drives the hunting culture also drives the intake of everything the fish were carrying. And a dolphin is an unusually good storage vessel for this. Its defining anatomical feature is a thick layer of fat wrapped around the entire body. The blubber that solves the thermal problem is also, chemically, a reservoir with an enormous capacity for exactly these compounds. The adaptation that makes the animal viable in cold water is the adaptation that makes it a collection point. Measurements from coastal bottlenose dolphins and other high trophic cetaceans have returned some of the highest PCB burdens recorded in any wildlife anywhere. In some populations, the loads found in blubber sit above thresholds associated with effects on immune function and reproduction, and the compounds involved were banned across much of the world decades ago. That's the part worth sitting with. Production largely stopped, and the levels in these animals did not correspondingly disappear because the molecules are still in sediments, still cycling, and still entering the food web from the bottom. So far, this is a slow poisoning, which is bad, but not surprising. Here is where it becomes something else. Blubber is not inert. It's an energy store. And there are two circumstances in a dolphin's life when the body draws that store down hard. The first is starvation, the spiral where a sick or unsuccessful animal burns its own insulation. When that happens, everything locked in the fat gets released into the bloodstream at once. The animal poisons itself in the act of trying to survive. The second circumstance is lactation. A nursing dolphin mother produces milk with extremely high fat content because a calf in cold water needs to build its own insulating layer fast. That fat is mobilized from her blubber, and whatever is dissolved in that fat goes with it. The contaminants transfer into the milk. The calf drinks them. This is called maternal offloading, and it is the single most uncomfortable fact in this entire story. A female bottlenose dolphin accumulates industrial compounds from every fish she eats, from birth through to her first pregnancy, potentially a decade of accumulation. Then she gives birth and nurses, and a large share of that accumulated burden moves out of her body and into the body of her first calf, in the milk, over months of feeding. The measured consequence is a divergence between the sexes that shouldn't exist. Male cetaceans in contaminated populations tend to show rising contaminant levels across their lives. They accumulate and never offload. Females often show high levels in their early years, then a sharp drop that corresponds with reproduction, and lower levels afterward. The mother becomes measurably cleaner. The route she cleaned herself by was her offspring, and the burden isn't spread evenly across her calves. The firstborn takes the worst of it, because it receives the accumulated load of everything she absorbed before she ever reproduced. Later calves are born to a mother who has already offloaded much of her lifetime store. The first one gets the archive. Now look at what that means for the animal we've been describing all along. Consider what a newborn bottlenose calf is already facing. It must swim from the moment of birth, and it must consciously breathe. Its mother goes weeks with almost no rest. Sharks target it specifically. Adult males of its own species kill calves in numerous populations. In many populations, a substantial share do not survive the first year. It has to learn, over years, the local hunting culture it will need to feed itself. And into that, in its first months, comes a concentrated dose of immunosuppressive and endocrine-disrupting compounds delivered by the only source of food it has. That's the collision. PCBs and related compounds are associated with suppressed immune function and impaired reproduction. Now put that alongside the epidemics. A population carrying heavy contaminant loads is a population with compromised immune defenses meeting a virus that also suppresses immune defenses in an animal that cannot isolate. Two mechanisms attacking the same system, arriving in the same water, in the same decade. Researchers have raised this connection repeatedly in relation to mass mortality events. That contaminant burden may be one factor making outbreaks more severe. The causal chain in any individual event is hard to pin down and shouldn't be stated with more confidence than the data supports, but the direction of the concern is well-founded and widely shared. And there's a reproductive consequence that runs longer than any single die-off. If contaminant exposure impairs the reproduction of animals in the most affected populations, then the effect isn't only on the calves that die. It's on the calves that are never born. Some heavily contaminated cetacean populations elsewhere in the world have shown very low reproductive output over long periods, with concern that recovery is being blocked rather than merely slowed. A population can be present, visible, and photographed daily while quietly failing to replace itself. And the mechanism doesn't care which mammal it ends in. The same concentration that climbs through plankton and small fish and larger fish into a dolphin climbs into anything else feeding at the top of that chain, which is why health advisories exist for high-trophic seafood and why they single out pregnant women specifically. Different species, same food web, same physics, same transfer through milk. The dolphin isn't a special case. It's the clearest one because it eats nothing else. It can't move away, and its entire body is built out of the tissue these compounds prefer. Now stand back and look at what this does to the story. For a long stretch, we've been examining a predator, coercive alliances, infanticide, killings without a clear motive, violence we could describe precisely and could not interpret. The whole arc was built on the gap between the friendly image and the animal underneath. This is the point where the direction reverses, because the compounds in that blubber weren't produced by any dolphin. They were made in factories, used in equipment, released into rivers and coastlines, and banned once the consequences became clear, decades ago, by people who then largely stopped thinking about it. The molecules stayed. They moved into sediment, into invertebrates, into fish, upward through the water, into the fat of an animal whose entire body plan is built to store fat. And then, through a mechanism nobody designed and nobody intended, into the milk. We are inside these animals, not metaphorically, measurably, in tissue samples, in the specific chemical signature of 20th century industry, in the bodies of newborn calves, in coastal water. Whatever the dolphins are doing to each other out there, it is happening inside bodies that we have already contaminated, which sets up the last thing, and the thing that makes all of it worse rather than better. Everything here would be a tragedy regardless of what kind of animal it happened to. Pollution in a food web is pollution in a food web. It would be the same chemistry in a shark or a seal. But this is not a shark or a seal. This is an animal that recognizes itself, that calls other individuals by name and remembers them across decades, that teaches, that maintains relationships lasting a lifetime and appears, by every behavioral measure we can apply, to keep track of exactly who it is dealing with. And that specific capacity is what turns our affection into a hazard, for them and for us. Put a mirror in the water, and most animals fail the same way. They look for the other one. They search behind the glass. They threaten it. They lose interest. What they don't do is check themselves. Bottlenose dolphins do. When researchers marked animals in places they couldn't see without a reflective surface, the dolphins went to the mirror and positioned their bodies to inspect the mark. Not the reflection as a rival, the reflection as information about themselves. It's the same test that a very short list of species has passed. Great apes, elephants, magpies, and dolphins have shown behavior consistent with passing it, including at ages younger than human children typically manage. Set the philosophical arguments aside. They'll run forever. What the test establishes at minimum is that this animal has a working model of its own body as an object separate from everything else. It knows where it ends. Now add the rest of what we've built. It has a name. Every bottlenose dolphin develops a signature whistle in its first months and keeps it for life, and other dolphins use it, copying a specific individual's whistle to address that individual, in the water, at a distance. Playback work has shown that animals respond to the signature whistles of dolphins they know. There is credible evidence that they respond to the whistle of an individual they have not seen in many years. Not a category. A specific animal, remembered across a stretch of time that covers a substantial part of a human life. It teaches. The sponging runs down family lines. The strand feeding takes years to learn, and a calf spends most of its childhood acquiring a body of local knowledge that exists nowhere in its genes. It never fully sleeps. It reads the insides of bodies with sound. It maintains nested alliances that require holding the political state of dozens of individuals in memory, updated continuously. That's the animal. Self-aware, named, remembering, teaching, permanently running, and, as this whole story has established, coercive, occasionally lethal, and completely unreadable from the outside. And here's the reframe, the one everything has been building toward. The terrifying thing about dolphins was never the violence. Violence in a social predator isn't news. You'd find worse in a chimpanzee troop, and nobody built a theme park around that. What should unsettle you is that we took an animal with this much going on inside it and decided on the basis of a curve of bone that it was a mascot. Then we acted on that decision, and the consequences land hardest on them. Start with feeding wild dolphins, which is illegal in many places for reasons that only became clear after the damage was done. A dolphin that learns to get food from boats begins associating humans with an easy meal. It stops hunting the way it should. It brings its calf, and the calf never properly learns the local techniques. The culture simply fails to transfer. Provisioned animals spend more time around vessels, and around vessels are propellers. In places where feeding became established, dolphins have been found with propeller injuries, with fishing gear damage, and with reduced calf survival. The kindness is what kills them. It's the most well-meaning way there is to shorten an animal's life. Then there are the lone sociable dolphins, individuals for reasons not fully understood, that separate from their group and begin seeking out human contact in a specific area. These animals become famous. People swim with them, touch them, feed them, and post the footage. And the pattern of what happens next has been documented enough times that it reads like a script. The animal is initially gentle. Interactions escalate. Swimmers get bolder, and so does the dolphin. Then someone gets hurt. Because an animal that weighs several hundred kilograms and pushes and mouths and rams as normal social behavior cannot scale that behavior down to something a human body tolerates. Injuries from these encounters include broken ribs, damaged organs, and in at least one documented case, a swimmer died following an interaction with a habituated wild dolphin. Read that against everything in this story. A bottlenose dolphin's ordinary repertoire includes ramming with the rostrum, holding things beneath the surface, and pushing objects around for extended periods. We already know what that does to a porpoise. Now the object is a person in a swimsuit, and the person is interpreting the interaction through a face that cannot change expression. The animals themselves usually end badly. Lone sociable dolphins are struck by boats, harassed, injured by people, and frequently found dead within a few years of becoming popular. The habituation that made them beloved is what removes their caution and captivity. The industry built entirely on the smile has its own arithmetic. Take an animal that ranges over enormous distances, hunts using techniques learned across years, maintains nested alliances with dozens of individuals, echolocates constantly into a world of varied acoustic texture, and place it in a concrete tank that returns its own clicks off flat walls, with a social group it did not choose and cannot leave. The evidence on welfare and on how these animals fare in that setting is contested and has been argued for decades. What is not contested is that visitors read the animal's face and concluded, without exception, that it was happy. It could not have shown them otherwise. That's the shape of the whole thing. Every harm here comes from the same source, not cruelty but affection aimed at an animal we invented. There's one more piece, and it's the largest by a long way, and almost nobody sets it next to the poster. In the eastern tropical Pacific, yellowfin tuna often swim underneath schools of dolphins. Nobody fully knows why the association exists. What the fishing fleets worked out from the middle of the 20th century is that you don't have to find the tuna at all. You find the dolphins, which are at the surface and visible from kilometers away, and you set a net around them, and the tuna comes up inside it. The dolphins came up inside it too. Animals that have to consciously swim to the surface to breathe, wrapped in netting, in enormous numbers, for decades. The kill from that fishery runs into the millions of dolphins across the period it went unchecked, which makes it one of the largest human-caused mortalities of any marine mammal on record. And it wasn't hunting. They were being used as a marker for something else. It changed under public pressure, labeling schemes and regulation, and the reported kill dropped by orders of magnitude. Some of the affected populations still haven't come back to what they were. Sit with the arrangement, because it's the whole argument in one image. Across the same decades, we were teaching children that dolphins rescue drowning swimmers. We were spotting them from the air and setting nets around them to sell tuna. The mascot and the bycatch were the same animal, in the same ocean, at the same time, and almost nobody who opened the tin ever had to think about it. So here's where it actually lands. The truth nobody talks about isn't that dolphins are killers. That's the version that goes viral, and it's just the mirror flipped over, us again, in a different mood, assigning a verdict to an animal that has no idea it's on trial. The truth is that we have never once looked at a dolphin. We looked at a shape and filled it with whatever we needed. Healer. In the decades when we wanted the ocean to love us back. Genius. When we wanted to believe in non-human language. Party animal. When we wanted them relatable. Sadist. When the darker footage arrived and we needed a new headline. 4 different animals, 1 species, 0 of them real. And underneath every version, the same thing has been swimming. A large-brained predator with a permanently running nervous system. A society more intricately structured than anything else in the ocean. A body that cannot stop paying its bills. A sense that goes through flesh. And no way whatsoever to tell us it is anything at all. That's not a monster. It isn't a friend. It's an animal, doing what 40 million years of evolution built it to do in a fluid that would kill you in an afternoon. The last image is the simplest one. Open water, late light, a single dorsal fin cutting a line, and then gone. Maybe it surfaces again, and you catch the face for a second. That curve, the one you've been reading your entire life. Look at it now. Nothing has changed. Not since the porpoise, not since the calf, not since the mirror, or the milk, or the 50 years of thinking you understood what you were seeing. The face never moved once. It never could.